Hello everyone. Uh, I hope I'm audible. So last time I think we had done till here, right? I told you what is the meaning of millimeter square. So millimeter square is basically milli square into meter square, right? Milli square into meter square. So multiplication of those two things. That's correct. It is not milli into meter square. No, right? So milli has also got a power 2 and meter also has got a power 2, right? That's what is right. So now let us talk about this stick. What is the length of this stick? 1 meter. So 1 meter is the length of the stick, right? Let's say. Now let's say one of you decides that I want to write the length of the stick in centimeter, let's say. I don't want to write it in meters. So what will be the length of the stick? You want to write in centimeter, let's say. How much would you say this is? You will say, well, it is 100 centimeters, right? Now 1 meter and 100 centimeters both represent the length of the stick, right? And let's say let L be the length of the stick. Right. So what will L be equal to? L will be equal to 1 meter, right? Okay. I just draw the symbol for my own reference. You don't have to copy this symbol, you know? I have to do something with this anyway. So see, so L is the length of the stick. L is equal to 1 meter, but you know L is also equal to what? 100 centimeters, right? So L doesn't change, right? Whether you write it in meters or you write in centimeter, L remains same. L is what? L is the physical quantity, the length, right? So the question is, does the physical quantity, which is L, the length of the rod or the stick, does it change if we change its units? If we change the units, does the length of the rod change? That's the question. And the answer is, does it change? Does the length of the rod change if I change the unit? The answer is no, it doesn't change, right? So what does it mean that? So L remains same, you know? And what is this? This is the number. 1 is a number, right? Written in which system? You will see that it is meter. Meter means it is written in MKS. And what is this? It's a unit. Written in which system? Again in MKS, right? Now what is this? This is also a number. Written in which system? In centimeter. So that means it is in CGS. What is this? It is a unit. Written in which system? In CGS, right? And they both are equal. So what can I write from here? I can write, let's take C for CGS and let's take M for MKS, you know? So what can I write? I can write left hand side becomes what? NCUC equals to NMUM, right? So that is the formula we end up getting. NCUC is equal to NMUM, right? That's a very important formula. So the question is, does the physical quantity change if we change its unit? The answer is no, right? And we get this formula out of here. And any physical quantity is a product of what and what? What is it product of? Any physical quantity Q is a product of this and this, means number, and the next quantity is unit. Right? It's made up of number and it is made up of unit. The product of number and unit. Any physical quantity is a product of number and unit, right? N and U. So basically the equation becomes, it's Q is equal to N into U. I'll write down here, Q is equal to N into U. Right? That's the formula. So you can take this down. Okay. So let's go ahead. That's what I was saying. Any physical quantity is a product of N and U. Right? So Q is equal to N into U. Now, if unit of length is centimeter in CGS, what is the unit of length in MKS? Let's say in CGS it is centimeter. So what is in MKS? What is the unit of length? It will be meter. If the unit of area is centimeter square in CGS, what is the unit of area in MKS? In CGS it is centimeter square. In MKS it is meter square, right? Because centimeter will become meter. What is the unit of density? If unit of density is gram per centimeter cube, what is the unit in MKS? So it is gram divided by centimeter cube. It is in which system? In the CGS system. Now we are going to write it in MKS. So can you guys tell me what will be in MKS? Gram will become kg, centimeter will become meter whole cube. So it becomes kg per meter cube. So if you know the units in CGS, you can write the unit in MKS also. This corresponding terms you have to change. Right? Then rho equals to 2 gram per centimeter cube. Convert it into MKS. So rho is density, right? And it is a It's a physical quantity. Right? And you have to write it in MKS. So we have this formula, if you remember, we just made this formula. What was the formula? NCUC is equal to NMUM. We made that formula. So let's use it. NCUC is equal to NMUM. Right? So what see, gram per centimeter cube is what? It is a units in which system? Gram centimeter means it is CGS, and this is a number written in which system? In the CGS, right? And we have to convert it into which system? Into MK system. In MK system, what is a unit? Like in CGS system, unit is gram per centimeter cube. In MK system, you know what is a unit? Tell me, what the unit will become? Gram will become what? Kg. Centimeter will become what? Meter. And cube is there, so cube will come, right? So we get kg per meter cube. Now what is kg per meter cube? This is the unit written in which system? Of course, in the MK system, right? Kg per meter cube is a unit written in MK system, right? And you will see that all the options 1, 2, 3, 4, A, B, C, D, all the options, they have, everybody has got the same unit, right? Unit is same. So unit is same in all the options, right? So we don't have to find a unit, which unit is correct. We don't have to make a judgment on unit because all the options have got the same unit. Now once we don't have to make a judgment on unit, we have to make a judgment on what then? What we have to decide? Whether it is true or not. What do we have to find out? Because units are same everywhere, or it's same case, you know. So what we have to decide on is not the unit, it is the number. We have to decide which number is correct out of these 4 numbers, which number is correct, right? So, and number written in which system? It's written in MKS, right? So let's clearly write down what we have to find. We have to find a number written in the system, MKS. That is what we have to find out. Number written in MKS, right? Basically, this we have to find out. Number written in MKS. NM. So what is NM coming out to be? NCUC divided by UM, and you can just plug the numbers now and get the answer. So what is NC equal to? NC is 2. UC is gram by centimeter cube. You know? Then divided by UM. What is UM equal to? UM is this part, you know, kg divided by meter cube. Okay. So let's simplify this further, and this will become okay. How do I move it around? Anyway, so this will be 2 gram centimeter cube, and we know centimeter cube is how much? I just told you is centi cube into meter cube, right? And what is the value of centi? Where c is equal to 10 to the power minus 2. That's equal to centi. The value of centi is 10 to the power minus 2. So what we are getting is gram divided by centimeter cube. That means it is centi cube into meter cube. Whole divided by kg divided by meter cube, right? That's what we're getting. Now you have gram, meter cube cancelled, and you end up getting 2 divided by k into c cube. Right. K is how much? 10 to the power 3. Centi is how much? 10 to the power minus 2. But you have a cube here. So whole cube. Okay. That will become 3 minus 6 is minus 3. This will go in the numerator. It will become 10 to the power 3. So we are getting 2000. So which option is correct? 2000 is this option. Right. So you can take down the whole question now. Let us convert 1 Newton to dyne. So first of all, what is 1 Newton? Let's see that part. What is 1 Newton to start with? So 1 Newton is unit of force written in this system in MKS. Right? And dyne is also unit of force. Both are unit of force only, right? Newton also and dyne also. Both are unit of force. But dyne is a unit of force in CGS. Right? So convert 1 Newton to dyne. So how will you do that? 1 Newton to dyne. So you see it's force, right? So first of all, let us see how to deal with force. Let's understand force. It has to be side. Verticals don't work. Fine. Oh, yeah. Okay, so let's go with let's write force. So we know that force is equal to mass into acceleration, right? And mass means kg, acceleration means meter per second square, and force means Newton, right? So those are the units. So we know that Newton is equal to kg meter per second square. Agreed? This is in which system? In MKS. Now let us write the same thing, but this time in CGS. Force is equal to mass into acceleration. Right? Let's write the units again, but this time in CGS. So what will be the unit of force in CGS? We know it is dyne, right? So we'll write it as D is equal to mass. Now what is the mass in CGS, guys? It's not kg, right? In CGS it is gram. It will be gram. Acceleration will be meter per second square. No, not meter. Instead of meter, you will have centimeter. Second square. Second will remain second only. So that's that. So we get that dyne, that is represented by the letter D, Newton by the letter N. So dyne is equal to gram centimeter divided by second square, right? So till here, I hope it is clear to everybody. Newton and dyne. Right, N for Newton and D for dyne. Okay, so we have to convert 1 Newton to dyne. How do you do that? 1 Newton to dyne. So we know that again, you see, you can recall we have a formula here. Didn't we make a formula here? Formula NCUC is equal to NMUM, right? Same thing will apply here also. NCUC is equal to NMUM. And how much we have, guys? We have 1 Newton, right? 1 Newton. We have to convert to dyne. So when you say 1 Newton, what is 1 here? 1 is a number written in the system. Newton means MKS. And this is unit written in the system, again in MKS, right? So you will see that we know NM, we know UM, right? And what is the unit of CGS, guys? Dyne. This fellow is a unit of CGS, right? Right. So we know this also. So we just have to figure out, I don't know the value of NC, and that's all we need to find out, right? That's the only thing. And it's very straightforward. No, you see, how do you find out NC? No worries at all. Easily find out NC. NC is coming out to be NM UM divided by US. That's it. Just put in the numbers now. NM. How much is NM? Hmm? NM is, where is it? There. NM is how much? Newton. What is UM? Sorry, NM is not Newton. NM is 1. What is UM? Unit is Newton divided by UC. UC is what? UC UC is dyne, right? So it's basically N upon D. You know, that's what NC is, N upon D. Now let us go and put the values of N. What is N equal to? N equals to this, right? And that is kg meter per second square divided by dyne. What is dyne equal to? Dyne equal to this. And what is that? Gram centimeter divided by second square. Right. Let's solve this. You see gram cancel, meter cancel, second square cancel, and we get simply K upon C. And if you plug in the values, K is 10 to the power 3, C is centi, which is 10 to the power minus 2. In total it becomes 10 to the power 3 plus 2, which is equal to 10 to the power 5, right? So what are we getting? We're getting the value of NC is 10 to the power 5, right? So NC is equal to 10 to the power 5. So if you put all the numbers here, let's call this equation number 1, and I can say putting all values in equation number 1, what do we get? We get NC value 10 to the power 5, UC value, UC is what? UC is dyne, is equal to NM is 1 and UM is Newton. So what did we get? We get 1 Newton is equal to 10 to the power 5 dyne, and that's the formula we wanted to make at the first place, right? So we got the formula. Write down. So similarly, you can try this 1 joule and erg relation. How much? What is it? So how is joule and erg related? Let's see. So 1 joule is unit of work in 1 joule is unit of work in which system? In the MK system. Erg is the unit of work in CGS. Right? And you have to convert 1 joule to erg. How do you convert that? Again, you can use the same formula, that Nm is equal to Nc Uc, right? Now, one joule. So what is one here? It is the number written in which system? Joule is what you see. It's a unit in MKS. So of course it is written in MKS. Joule is as I said, is a unit in MKS. Unit of what? Unit of work. Right. 1 second. Okay. So 1 second. We have covered the this part also, right? Unit and dimensions. Fine. So we have done dimensions also. We are very close to ending the chapter now. Right. So this is Nm, this is Um, and erg is what? It is unit of work in CGS. This is a unit of work in CGS. So that means we know Nm, we know we know Uc also. We just have to find out Nc. And to find Nc, it is very straightforward. Nc is equal to Nm divided by Uc. Just put in the numbers. Nm is what? 1. Is joules. J. Uc is what is Uc? Uc is erg. Let's write it as E. Erg. So it's basically joule upon erg will give you Nc that we're looking for, right? The only Nc we don't know, we can find out just joule by erg. That means you have to find joules, you have to find ergs, simplify them and put it there to get the relation. So how do we find out joule and erg values? Let's see how to do that part. What is joule? Let's find out. So it's work, right? You know, work is equal to what? Force into distance. And if you want to write unit, what is unit of work? Joules. What's the unit of force? Newton. Distance, meter. But similarly, this is in which system I've written? I've written in MKS, right? Now also let us write it down CGS also. In CGS it will become what? Work will become erg. Force will become, what is force in CGS, guys? Remember we did here. Force in CGS is Mr. Dyne, right? Mr. Dyne. So we get Dyne, and distance means centimeter, right? Because it is in CGS. CGS distance is centimeter, and force is Dyne, right? So we have written it in CGS also, as well as in MKS also. Both we have written. Okay. And to find out NC, I need J upon C, right? And I have the values, don't I? I have J, I have C. J is what? Where is J? J value I can take and substitute it here. E value I can take and substitute it here, right? And then I will get my answer, what I'm looking for. So NC is coming out to be what? J upon E. And J value, how much are we going to put? NM. E, how much are we going to put? E value? DCM. M is meter, gets cancelled, right? There it is. NC. It's just N by DC. But if you recall, what is N after all, guys? N is something we know, right? What is N? Here it is. You will see that N is nothing but d to the power 5, so n to 10 to the power 5d. That's what is N, right? N is 10 to the power 5d. Put it here. 10 to the power 5d. That's what N is. 10 to the power 5d divided by dc. D goes out. Dyne cancel, right? And we get 10 to the power 5 divided by c. But what is c after all? C is made up of 10 to the power minus 2, which goes up and becomes 10 to the power 7. So that's what is NC, 10 to the power 7, right? Now we have got NC. If we use this value of NC and put it right here, so see what does this entire thing gives us? What do we end up getting? We end up getting this. NM is how much? 1. So we get 1. UM is joules. We get 1 joule is equal to how much exactly? NC. And NC is what? 10 to the power 7. NC is 10 to the power 7 into UC. And UC is what? Erg. So we proved that 1 joule is actually equal to 10 to the power 7 ergs. And these are absolutely basic quantities, so you should completely understand this, right? And let me know if there's any doubt with this. right? So now let's go to the next topic, which is acceleration due to gravity is 9.8 meter per second square in MKS. What is its value in CGS? Right. So to basically convert 9.8 meter per second square in CGS and see how much it comes out to be. Right. That you try yourself. This as a homework, and this is also a homework. Right. Basically all our homework now because we are done with the chapter. Right. So all the remaining problems are homework. I will in the next class I will probably do one or two more problems and then we'll move to the next chapter, which is vectors, right? So you try solving these problems or you can try solving your book problems, DPP problems, and try yourself problems, right? And if you have any doubt you can ask me in the next class. We'll address that before moving to the next chapter, right? That'll be all.